Here's example 4. We're going to solve a real life problem. We're going to look at it step by step here. So in this real life problem, you're going to notice that it sounds pretty familiar. We've done a lot of questions like this. The function f of t equals negative 16t squared plus s sub 0 represents the approximate height in feet of a falling object t seconds after it's dropped from an initial height of s sub 0 in feet. An egg is dropped from a height of 64 feet. After how many seconds does the egg hit the ground? And then suppose that the height is adjusted by k feet. How will this affect part A? So let's go step by step. First, let's understand the problem. You know the function that models the height of the falling object and the initial height of the egg. You're asked to find how many seconds it takes for the egg to hit the ground when dropped from the initial height. Then you need to describe how the change in initial height affects how long it takes to hit the ground. Let's make a plan. Use the initial height to write a function that models the height of the egg. Use a table to graph the function. Find the zeros of the function to answer the question. Then explain how the vertical translation of the graph affect the zeros. Remember, the zeros are where the graph crosses the x-axis. So that's what we're going to look for. We're going to solve the problem. The initial height is 64. So when I plug 64 into the formula, the function is f of t equals negative 16t squared plus 64, represents the height of the egg t seconds after it is dropped. The egg hits the ground when f of t equals 0. Remember, the ground has a height of 0, so we want it to equal 0. We're going to make a t-table. When we make a t-table here, we're going to start with 0 as the first point because we can't have negative time. So I'm going to have the 0, which is going to be where our vertex is, and then I'm only going to go up numbers here. And in my table, I'm going to go up until I get a y value of 0. And this is really the point that I'm looking for here because this is when the height is 0, when the egg will hit the ground. Now I can plot those points on my coordinate plane. So that means the egg will hit the ground 2 seconds after it is dropped. When the initial height is adjusted by k feet, the graph of f is translated up k units when k is greater than 0, or down k units when k is less than 0. So the x-intercept of the graph will move right when there's more time or left when there's less time. Let's look at another example like this and let's let Big Ideas explain it.
The function h of t equals negative 4 9/10 t squared plus s sub 0 represents the approximate height in meters of a falling object t seconds after it is dropped from an initial height s sub 0 in meters. A coin is dropped from an initial height of 44 1/10 meters. Part A. After how many seconds does the coin hit the ground? Because the coin is dropped from an initial height of 44 1/10 meters, the function h of t equals negative 4 9/10 t squared plus 44 1/10 represents the height of the coin t seconds after it is dropped. The coin hits the ground when h of t equals 0. Make a table of values. Substituting 0 for t in the function h gives h of t equals 44 1/10. Similarly, when t equals 1, h of t equals 39 2/10. When t equals 2, h of t equals 24 5/10. And when t equals 3, h of t equals 0. So to sketch the graph, plot the ordered pairs 0, 44 1/10, 1, 39 2/10, 2, 24 5/10, and 3, 0.
Notice how they kept going with the table until they reached a y value of 0. They didn't just stop at 2. They had to go one more to when the t is 3 in order to get a height of 0.
Then draw a smooth curve through the points. Next, find the positive 0 of the function. When t equals 3, h of t equals 0, so the 0 is 3. So the coin hits the ground 3 seconds after it is dropped. Part B. Suppose the initial height is m meters lower. How will this affect part A? When the initial height is lowered by m meters, the graph of h is translated down m units, so the x-intercept will move left. So the coin will take less than 3 seconds to hit the ground.